Hi friends, today we are going to talk about operations with complex numbers. This video is going to be for add, subtract, and multiply. I'm going to have a separate video for dividing complex numbers. So if that's what you're looking for, it's a separate video. All right. So the first thing I want to talk about are like terms. Now I've talked about like terms really often because it's such an important thing. So when we introduce complex numbers, remember now we have numbers with an I. And a complex number might look like 3 plus 4i. Now, you might think of that as two numbers together, but it's actually one complex number. It has a real part and a complex part that make up the single complex number. So when we talk about like terms, the real part can be added together or subtracted, and the complex part can be added or subtracted together. But we cannot combine the real part and the complex part. So for example, if I had 3i plus 7i, those are like terms and they can get combined together to make 10i. So like terms. So they had exactly the same I part, and the 3 and the 7 are like terms. Similarly, if I had 2xi plus 5xi, these are also like terms. The I and the x are exactly the same, so we can add the 2 and the 5 to get 7xi. Again, like terms. All right, what if I had 2xi plus 3i? Well, unfortunately, this one has an x, this one doesn't. These are not like terms. So this becomes important as we are dealing with the operations on complex numbers. Okay, so when we do operations with complex numbers, here's our rule. We're going to treat I like a variable. Meaning we can add, subtract, and multiply it just like it's a variable, except for one important case. We never want to leave anything bigger than I to the first power. So I squared is equal to -1. So anytime we have something bigger than I to the first power, say an I to the second, I to the third, we want to rewrite it using this fact right here. I squared is equal to -1. So let me show you what I mean. We're going to start with multiplication. Why not? We always start with addition. Multiplication needs a chance. Let's say I have 2i times 3 minus I. Now, I said treat I like a variable, except for when you see I squared. So we're going to treat I just like a variable, and we're going to multiply in this 2i and distribute it to everything in the parentheses. So 2i times 3 is going to give me 6i. 2i times -I would give me minus 2i squared. All right, so far so good. We treated I like a variable. I cannot combine these two things because they're not like terms, except for now I have an I squared. So in place of my I squared, I am going to write what I squared is equal to -1. I'm going to rewrite this as 6i minus 2 times -1, which would be 6i plus 2. All right, perfectly good answer. However, convention tells us that we write the number part first and then the complex part. This is called standard form. So I'm going to rewrite this as 2 plus 6i. And that is the answer I would want to give at the end, although the answer above it, 6i plus 2, is not wrong. All right? Let's look at adding and subtracting these complex numbers. Adding and subtracting works exactly the way you think it should. So if I add 4 plus 3i plus 2 minus 5i, and I've put my complex numbers in parentheses just to separate them. Those parentheses don't really mean a whole lot other than I'm separating one complex number from another. All right, we are adding, so we can drop those parentheses and just write it as 4 plus 3i plus 2 minus 5i. And then thinking back to simplifying in like terms with variables, we're going to group our number part together, the 4 and the 2, to get 6. And then we will group our I parts together, 3i minus 5i, to get negative 2i. And our final answer would be 6 minus 2i. Subtraction takes a little bit more care because we have a negative that gets distributed. So I have a complex number in parentheses, minus 1 plus 10i, close parentheses, minus, again, we're going to open another set of parentheses, 3 minus 2i. So we are subtracting two complex numbers. Now in this one, the first set of parentheses just sets off that complex number to say, hey, I'm a complex number. These two things go together. The second set of parentheses does the same thing, but it also reminds us that the negative gets applied to both things in that second set of parentheses. So we have to multiply that negative into the parentheses. On that next line, I'd have negative 1 plus 10i, just bringing down that previous line and dropping the parentheses off of it. And then negative gets multiplied by 3 to make negative 3, and negative times negative 2i gives me positive 2i. Now we have something that looks like an addition problem, and we can finish it up by grouping up our like terms, negative 1 and negative 3. Pulling those together, I have negative 4. And then positive 10i plus 2i gives me plus 12i. I have it in standard form because the number part is first and the complex part is after. So my final answer would be negative 4 plus 2i. All right, let's look at one more, probably two more. All right, I'm going to make it a little bit more complicated. So I have 4i times 1 minus I in parentheses, minus 2 times 3 plus I in parentheses. Okay, so we have quite a bit of parentheses here to deal with. Let's just take it one step at a time. So we'll take that 4i and multiply it times the 1 and by the negative I. So I have 4i minus 4i squared. Oh, when you see that I squared, we want to think, gotta simplify that. We'll come back to it. All right, for the second set of parentheses, I'm going to multiply that negative 2 times the 3 and the I. So I'll have negative 2 times 3 gives me minus 6, and negative 2 times I is minus 2i. Okay, I see some like terms I can combine. I have a 4i and a minus 2i that can combine together. So I'm going to rewrite that as 2i. Then I have a minus 4i squared minus 6. Remember that we said I squared is equal to -1. So in place of I squared, I'm going to write -1. So this would actually be equal to 2i minus 4 times -1 is plus 4 minus 6. And then I have like terms I can combine. Plus 4 and minus 6 is going to give me 2i minus 2. Now, that's not in standard form, so let's rewrite it. Notice that the minus goes with the 2, so this would be a minus 2. Oop, not an I. That's not what I wanted. All right. Oop, made a mess there. All right, so minus 2i minus 2 plus 2i. So that minus goes with the 2 here to come down here. The 2i is positive, so it stays positive, and we end up with our answer in standard form. Let's look at one more. And this one is going to be another complex number multiplied by a complex number. I did one over here where we just had one term multiplied into the parentheses, and I'd like to do one more. So this is going to be, in parentheses, 5 minus 2i multiplied by, in parentheses, 4 plus 6i. Now remember, I said we're going to treat I just like a variable until we get to an I squared. So if this I were an x, we would be very comfortable foiling this out. And we're going to treat the I just the same we would as if it's an x. So first terms first, 5 times 4 is going to give me 20. Outside, 5 times 6i is going to give me 30i. Inside, minus 2i times positive 4 is a minus 8i. And then last terms, minus 2i times positive 6i gives me 12i squared. All right, there's two things I'd like to do. One is I have some like terms here that I can combine, 30i minus 8i. The other one is I squared can be rewritten as -1. And I do, when I'm working these out, I'll just circle that I squared and write a -1, indicating that I'm replacing I squared with -1, so that when I look back at my work, I know what I did. All right, so I'm going to have 20 plus 30i minus 8i is 22i. And then I have minus 12 times minus 1 is positive 12. Last, I can group my real parts together because they are like terms. So 20 plus 12 will give me 32. And then I still have a 22i. Remember, the real part gets written first, then the complex part. So we would want to write that answer as 32 plus 22i. All right, in much of college algebra, these are the operations that you will need. I'm going to do a separate video discussing dividing complex numbers so that if you need that skill, you have that for reference.